Lesson 17.2, Task 1. Factor quadratic expressions of the form x squared plus bx. Remember, quadratic means it has an x squared term. It's a U-shaped graph or called a parabola. All right, so x squared tells us that this is quadratic. Remember, linear was something to the first power. Now we're looking at quadratic expressions. All right, so the greatest common factor, GCF, of an expression is the product of the greatest integer and the greatest power of each variable that divide evenly into each monomial of the expression. An expression such as x squared plus 3x can be factored using a common factor. Each term in the expression has a common factor of x because each term is divisible by x. So if we look at this, we have x squared plus 3x, and they have rewritten x squared. You know, x squared is just something times itself. So they have x squared plus 3x, and all they're doing is rewriting this expression as x times x. Because remember, properties of exponents, same base, you would add your exponents, and when there's no exponent, you assume that to be a 1, so 1 plus 1 would be 2. So that's how they write this as x times x and then plus 3x. So this is equivalent to this. Now, why are we doing that? We're looking for a greatest common factor. So if you look, you can see that both of these have an x in common. So you're looking at your monomials. Remember, a monomial is separated by a plus or a minus sign. So we have two monomials here, and they both have a common term. So we're going to bring out the x. So that accounts for this. And then we have x plus 3 left. All right, so this is called factored form. This is in standard form, and this is factored form. And we know that these two expressions are equivalent because if I do distributive property, x times x is x squared. X times 3 is 3x. So this is just rewriting an expression in a different form, okay? So again, you can check that by quickly distributing and seeing that x squared plus 3x is the same thing, just written in a different way. All right. It says factoring enables you to rewrite an expression in an equivalent form that can reveal properties of the quantity the expression represents. A developer wants to construct buildings on different size square lots in a city. The city has a setback rule that requires buildings to be a minimum distance from the street. The development company plans to use the entire area that is allowed to build on. All right, so there's an image or a picture here, and you can see that this side is x feet long and this side is x feet long, and that's the buildable area. Again, in the city rules, there's a 15 feet setback. So it does say a minimum distance is 15 feet from the road. So the buildable area of a square lot is x squared minus 15x, where x is the size length of the lot in feet. All right, so what do the expression x squared and 15x represent in the context? Select the phrases to complete the statements. The expression x squared represents the total area. Okay, you can see x times x, it's a square lot, so the area would be side times side or side squared. The expression 15x represents the area of the portion of the lot that is not buildable. That's the part that's close to the road, that the setback zone from the city. All right, so the greatest common factor of x squared and 15x is, all right, so this is x times x, and this is 15x, so they both have an x in common. All right, so it says, what is the factored form of the buildable area? All right, so if you think about x squared minus 15x, we're going to have this is written as x times x again, minus 15x. They have an x in common, so I'm going to pull out the x, and then I have x minus 15 left. Okay, so once you factor this out, then you just see what's left. So x times x is x squared, x times minus 15 is minus 15x. Again, this is just factored form, and this is standard form. These are two different expressions that are equivalent. So it says, which is the factored form of the buildable area? X times x minus 15. All right, so it says select the expressions to compare the statements. The minimum number of feet that the building must be set back from the street is 15. If you go back to the picture, you can see that they set back 15 feet from the road. And it says the side length of a lot must be greater than 15 feet. All right, so the side length of the lot must be greater than 15 feet. If it weren't, there wouldn't be enough space for the building. All right, if the developer chooses to construct a building on a square lot with a side length of 60, what is the maximum area of one floor of the building? All right, so we can use our calculator to solve this. So what we're going to do is just simply plug in 60 for x. You can use factored form or standard form. So let's see what happens if we plug in 60 here. So we're going to have 60 squared minus 15 times 60. So 2,700 square foot. All right, so again, just to make sure you know what I'm doing here, all I did was take 60 and I squared it and then minus 15 times 60. So I just plugged in the number given to x. You could also plug it in here, 60 times 60 minus 15. And that would give you the same answer. So it doesn't matter if you use standard form or factored form when you are substituting a number in to find the area. All right, that's all for task 1. If you have any questions, let me know. Lesson 17.2, task 2. Factor quadratic expressions of the form x squared plus bx plus c. The distributive property can be used to expand the product x plus p times x plus q. The result is a quadratic expression of the form x squared plus bx plus c, where b is the sum of the constants p and q, and c is the product of p and q. All right, so you can see, all right, we will look here. They've got it laid out here, but let's look at it ourselves. So we got x plus p times x plus q. All right, so if we use distributive property, some of you guys use the box method, some of you just multiply by each thing, but we can do x, well, if I can get my pen to work here, x, so I take my first term and multiply it by both of these, and then I do the second term, p, times both of these. All right, so x times x is x squared plus xq, and then I've got plus px, so I'm going to put xp, and then plus pq. So you can see that these have a common factor here, so we've got x squared plus x times p and q. The order doesn't matter when it's commutative property, so I've got q plus p, but q plus p is the same as p plus q, and then plus pq. So you can see that what I have written here is what they have, and it's just another way to look at factored form. So distributive property is what we're looking at. So again, this is factored form, and this is standard form, and they're just using variables to kind of look at this process. All right, so it says the goal of factoring is to reverse the process of starting with a quadratic expression and finding integer values of p and q so that x squared plus bx plus c equals this factored form. Okay, so that's what we're looking for. All right, so it says suppose you want to write x squared plus 8x plus 12 in the factored form. All right, identify the value of c. So remember our quadratic, we've got a, b, and c. So c would be our constant term, which is 12. All right, it says to help identify p and q, what are all the factors of c? So we just said that c is 12. So all of our factors of 12, and you need to be really good at multiplication if you're going to be good at factoring. So 1 and 12, 2 and 6, 3 and 4. So those are considered our factors of 12. All of these multiply together to give me 12. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. So we're going to choose all of our factors of 12, 1 and 12, 2 and 6, 3 and 4. All right, so it says remember that b equals p plus q. Use this fact and the fact that p and q must be a factor pair of c to find the values of p and q to complete the statements. All right, so go back up here and let's see what b is. All right, so we've got x squared plus 8x plus 12. So we know c was 12, and now we know that b equals 8. All right, so we're going to use that. We know that b equals p plus q. So these two have to equal 8. 1 and 12 does not equal 8. 2 and 6, yes, that equals 8. 3 and 4 equals 7. So 2 and 6 have to be our values. So the lesser value is 2 and the greater value is 6. So that's how we determine what numbers goes in our factor. All right, so it says which expressions shows x squared plus 8x plus 12 in factored form. All right, so we said that 2 times 6 multiplies to give us 12, and 2 plus 6 adds to give us 8. So our factors will be x plus 2 and x plus 6. And the order of which the factors does not matter. The sign matters and the numbers matter. And since both of these have positive signs, then it will be positive signs in the factors as well. Now, let's check it. Okay? So if we have x plus 6 and x plus 2, I'm going to use distributive property to multiply this out. And I'm going to have x squared plus 2x plus 6x plus 12. If I combine those, there's my 8x, that's my p and q I'm combining, and 12x. So yes, this factored form does equal the standard form when we check it. And it's not a bad idea to multiply it out and check things. All right, so it says, how can you use the factored pairs you found in part A to factor this expression? So this expression is very similar, it just has a negative sign. So the new values P and Q should have the same product, because it's still going to equal 12 as the original problem, and the opposite sum. So the product is still 12, the sum is negative 8 instead of 8. So you need to change the sign of one of your values. Oh, wait a minute. Oh, sorry. You're going to change the sum of both values because two negatives will be a positive when you multiply.